Hello everyone, welcome to this new series dedicated to AP Precalculus. My name is Rami and I'm excited to guide you through some key concepts and problems that you will encounter on the AP Precalculus exam. In this series, we will break down various AP Precalculus questions step by step, making complex topics easier to understand. Whether you are a beginner or just looking to reinforce your skills, this series is designed to help you feel confident and prepared. So let's dive in and start tackling those AP Precalculus problems together. Once you open the Blue Book application and sign in using your College Board student account, you will then navigate to the Practice and Prepare section. From there, you can access a variety of test previews and practice materials to help you get ready. Which of the following functions has a zero at x equals 3 and has a graph in the xy plane with a vertical asymptote at x equals 2 and a hole at x equals 1? What does this mean? Yes, if we have a graph with a x and y axis at x equals 3, 0, that means if we have 1 and 2 and 3, root a 0 at x equals 3, that means we have a root at x equals 3. And vertical asymptote at x equals 2, that means we have some kind of a unreal line that this rational function will not touch this, the equation of this line x equals 2, and a hole at x equals 1, that means we have the somehow in this way. That means here is undefined by value. That means 1 undefined, as we're going to confirm that with the Desmos later. This question, no calculator is allowed. So what we're going to do now are 0 at x equals 3 and a vertical asymptote at x equals 2 and a hole, this is a hole at x equals 1. So let's just take this away a little bit. Yes, just take it here. Now, in order to do that, please, we have to factorize all of the above. We have to factorize all of the above answers. We're gonna discuss those later. A, h of x is a rational function. X, it's a quadratic equation, x and x. Since this positive, so the sign of both factors will be the same as the sign of the middle term, negative. So we write negative and negative. And we know that 3 by 1 to make sure. So negative 3, negative 1, that give us negative 4, which is the middle term. Okay, the middle term, so our answer is correct. The denominator, right, it's a quadratic equation also. X positive, so the sign of both factors will be the same as the middle term in sign. Negative, negative, 2, 1. This is choice number A. What about choice number B? Change the color. B equals 2. Here we go. The denominator is the same. So it will be x negative 2 and x negative 1. The numerator, it's a quadratic equation. So it will be x and x positive. So the sign will be the same as the sign of the factor will be the same sign as the middle term. So negative and negative. So what are the both number that will, the multiplication of them equals to 6 and the addition of them equals to negative 5. Those are negative 2 and negative 3. Negative 2x, negative 3x, the summation of them equals to negative 5x. And choice number C, k of x equals x negative 3 over the same thing, x negative 2 and x negative 1. And the last choice, which is D, m of x equals to x negative 3. And this formula is different than the previous one. So we have to factorize it again. X, the sign of the last term is positive. So both sign will be the same as the sign of the middle term, negative. And here, so negative 3, negative 1. So what is required here? 1, 0 at x equals 3. 2, vertical asymptote at x equals 2. And the third require whole at x equals 1. 0. So the first requirement is 0 at x equals 3. So the first choice, 0 at x negative 3. We have x negative 3, and here x negative 3, and here is x negative 3, and x negative 3 in the denominator, but x negative 3 is repeated up and down. That means we have a whole at x equals 3. It is a whole, not 0. X equals 3, not 0. So we can eliminate the first choice. So this one, with respect to the choice number 2 and 3, we have to look at the denominator. X equals 2, that means we have to look x negative 2 at the denominator. We have this one, and we have this one, and we have this one, so we cannot eliminate. A whole at x equals 1, that means x equals 1, that means x negative 1 equals 0. This is what we are looking for. In order to have a whole for a rational function at x equals 1, we have to have x negative 1 at the numerator and x negative 1 at the denominator. So we have this choice. We don't have x negative 1 at the numerator. We can eliminate this. And also we don't have x negative 1 at the denominator in here. So our answer should be, if we return back here, so this is our correct answer. If we go back to the Desmos, we can see that we have a vertical asymptote at x equals 2. We just write x equals 2, we're going to see that this function don't touch the vertical asymptote at x equals 2. And if we just zoom here, we can see this is our 0, 3, x equals 3, and it will cut the x-axis at x equals 3. And since it cuts the x-axis at x equals 3, so absolutely our y equals to 0. And if we just write f of 3, the answer equals to 0 here. What about the whole? We know that it should be somehow there will be a whole at x equals 1. If you just move the mouse, you're gonna see it will change at x equals 1. It's undefined. At x equals 1, there is a whole. It's undefined, okay? So if you just write f of 1 equals to undefined, since it is a whole. Since it is a whole, as you can see, here it's closed, but if you just go to 1, okay, it will change the color. I'm trying to, here we go. Yes, right, it will give you an empty circle, undefined, since it is a whole at x equals 1. So x negative 1 is a factor at the denominator. And that's how we complete solving this question. I hope you found some new insights and enjoyed the video. Don't forget to share it with your colleagues and subscribe to the channel for more helpful content.